Hydraulic mining, or hydraulicking, is a form of mining that uses high-pressure jets of water to dislodge rock material and move sediment. In the place of mining of gold.It, the resulting water-sediment slurry is directed through sluice boxes to remove the gold. It is also used in mining kaolin and coal. Hydraulic mining originated out of ancient Roman techniques that used water to excavate soft underground deposits. Its modern form, using pressurized water jets produced by a nozzle called a monitor, came about in the 1850s during the California gold rush in the United States. Though successful in extracting gold-rich minerals, the widespread use of the process resulted in extensive environmental damage, such as increased flooding and erosion, and sediment blocking waterways and covering over farm fields. These problems led to its legal regulation. Hydraulic mining has since been used in various forms around the world. History. Precursor. Ground sluicing. Hydraulic mining had its precursor in the practice of ground sluicing, a development of which is also known as hushing, in which surface streams of water were diverted so as to erode gold-bearing gravels. This was originally used in the Roman Empire in the 1st centuries AD and BC, and expanded throughout the empire wherever alluvial deposits occurred. The Romans used ground sluicing to remove overburden and the gold-bearing debris in Las Medullas of Spain, and WorldCat in Britain. The method was also used in Elizabethan England and Amp, Wales for developing lead, tin and copper mines. Water was used on a large scale by Roman engineers in the 1st centuries BC in AD when the Roman Empire was expanding rapidly in Europe. Using a process later known as hushing, the Romans stored a large volume of water in a reservoir immediately above the area to be mined. The water was then quickly released. The resulting wave of water removed overburden and exposed bedrock. Gold veins in the bedrock were then worked using a number of techniques, and water power was used again to remove debris. The remains at Las Medullas and in surrounding areas show badland scenery on a gigantic scale owing to hydraulicking of the rich alluvial gold deposits. Las Medullas is now a UNESCO World Heritage Site. The site shows the remains of at least 7 large aqueducts of up to 30 miles in length feeding large supplies of water into the site. The gold mining operations were described in vivid terms by Pliny the Elder in his Naturalis Historia published in the 1st century AD. Pliny was a procurator in Hispania Terris Onensis in the 70s and must have witnessed for himself the operations. The use of hushing has been confirmed by a field survey and archaeology at WorldCat in South Wales, the only known Roman gold mine in Britain. California gold rush, the modern form of hydraulic mining, using jets of water directed under very high pressure through hoses and nozzles at gold-bearing upland paleogravels, was first used by Edward Mattison near Nevada City, California in 1853 during the California gold rush. Mattison used canvas hose which was later replaced with kaolin hose by the 1860s. In California, hydraulic mining often brought water from higher locations for long distances to holding ponds several hundred feet above the area to be mined. California hydraulic mining exploited gravel deposits, making it a form of placer mining. Early placer miners in California discovered that the more gravel they could process, the more gold they were likely to find. Instead of working with pans, sluice boxes, long toms, and rockers, miners collaborated to find ways to process larger quantities of gravel more rapidly. Hydraulic mining became the largest scale and most devastating form of placer mining. Water was redirected into an ever-narrowing channel through a large canvas hose and out through a giant iron nozzle called a monitor. The extremely high-pressure stream was was used to wash entire hillsides through enormous sluices. By the early 1860s, while hydraulic mining was at its height, small-scale placer mining had largely exhausted the rich surface places, and the mining industry turned to hard rock hydraulic mining, which required larger organizations and much more capital. By the mid-1880s, it is estimated that 11 million ounces of gold had been recovered by hydraulic mining in the California gold rush. Environmental consequences, while generating millions of dollars in tax revenues for the state and supporting a large population of miners in the mountains. Hydraulic mining had a devastating effect on riparian natural environment and agricultural systems in California. Millions of tons of earth and water were delivered to mountain streams that fed rivers flowing into the Sacramento Valley. Once the rivers reached the relatively flat valley, the water slowed, the rivers widened, and the sediment was deposited in the floodplains and riverbeds, causing them to rise, shift to new channels, and overflow the banks, causing major flooding, especially during the spring melt. Cities and towns in the Sacramento Valley experienced an increasing number of devastating floods, while the rising riverbeds made navigation on the rivers increasingly difficult. Perhaps no other city experienced the boon and the bane of gold mining as much as Marysville, situated at the confluence of the Yuba and Feather Rivers. Marysville was the final jumping-off point for miners heading to the northern foothills to seek their fortune. Steamboats from San Francisco, carrying miners and supplies, navigated up the Sacramento River, then the Feather River to Marysville, where they would unload the passengers and cargo. Marysville eventually constructed a complex levee system to protect the city from floods and sediment. Hydraulic mining greatly exacerbated the problem of flooding in Marysville and chilled the waters of the Feather River so severely that few steamboats could navigate from Sacramento to the Marysville docks. The sediment left by such efforts were reprocessed by mining dredges at the Yuba gold fields located near Marysville. The spectacular eroded landscape left at the site of hydraulic mining can be viewed at Malakoff-Diggins State Historic Park in Novato County, California. A similar landscape can be seen at Las Medulas in northern Spain, where Roman engineers ground-sluiced the rich gold alluvial deposits of the river sill. Pliny the Elder mentions in his Naturalis Historia that Spain had encroached on the sea and local lakes as a result of ground-sluicing operations. Legal consequences: vast areas of farmland in the Sacramento Valley were deeply buried by the mining sediment. Frequently devastated by floodwaters, farmers demanded an end to hydraulic mining. In the most renowned legal fight of farmers against miners, the farmers sued the hydraulic mining operations, and the landmark case of Edwards Woodruff v. North Bloomfield Mining and Gravel Company made its way to the United States District Court in San Francisco, where Judge Lorenzo Sawyer decided in favor of the farmers and banned hydraulic mining on January 7, 1884, declaring that hydraulic mining was a public and private nuisance and enjoining its operation in areas tributary to navigable streams and rivers. Hydraulic mining on a much smaller scale was recommenced after 1893 when the United States Congress passed the Caminetti Act, which allowed such mining if sediment detention structures were constructed. This led to a number of operations above sediment catching brush dams and log crib dams. Most of the water delivery hydraulic mining infrastructure had been destroyed by an 1891 flood. so this later stage of mining was carried on at a much smaller scale in California. Beyond California, although often associated with California due to its adoption and widespread use there, the technology was exported widely to Oregon, Colorado, Montana, Arizona, Idaho, South Dakota, Alaska, British Columbia, and overseas. It was used extensively in Dahlonega, Georgia, and continues to be used in developing nations, often with devastating environmental consequences. The devastation caused by this method of mining caused Edwin Carter, the log cabin naturalist, to switch from mining to collecting wildlife specimens from 1875 to 1900 in Breckenridge, Colorado, USA. Hydraulic mining was also used during the Australian gold rushes, where it was called hydraulic sluicing. One notable location was at the Oriental Claims near Omeo in Victoria, where it was used between the 1850s and early 1900s, with abundant evidence of the damage still being visible today. Hydraulic mining was used extensively in the Central Otago gold rush that took place in the 1860s in the South Island of New Zealand, where it was also known as sluicing. Starting in the 1870s, hydraulic mining became a mainstay of alluvial tin mining on the Malay Peninsula. Hydraulicking was formerly used in Polk County, Florida to mine phosphate rock. Contemporary usage. In addition to its use in true mining, hydraulic mining can be used as an excavation technique, principally to demolish hills. For example, the Denny regrade in Seattle was largely accomplished by hydraulic mining. Hydraulic mining is the principal way that kaolinite clay is mined in Cornwall and Devon, in southwest England, on the South African Rand goldfields. A gold surface tailings retreatment facility called East Rand Gold and Uranium Company has been in operation since 1977 using hydraulic monitors to create slurry from older tailings sites and pumping these long distances to a concentration plant. The facilities process nearly 2.0 million tons of tailings each month at a processing cost of below $3 per t. Gold is recovered at a rate of only 0.20 grams t, but the low yield is compensated for by the extremely low cost of processing. No risky or expensive mining or milling is required for recovery. The resulting new slimes are pumped further away from the built-up areas, permitting the economic development of land close to commercially valuable areas and previously covered by the tailings. The historic yellow-colored mine dumps around Johannesburg are now almost a rarity, seen only in older photographs. Uranium and pyrites are also available for recovery from the process stream as co-products under suitable economic conditions. Underground hydraulic mining. High-pressure water jets have also been used in the underground mining of coal, to break up the coal seam and wash the resulting coal slurry toward a collection point. The high-pressure water nozzle is referred to as the hydro monitor.